Zoom record. Okay, there we go. Anyway, so when we're looking at changing from normal, from decimal to scientific notation, you want to remember that if it's larger than 1, it's going to be positive. If it's less than 1, it's going to be negative. And the other thing you want to remember is the rule that says that the first digit to the left of the decimal point has to be between 1 and 9. So for this one, would be letting me do changes. It would be 7.3. I don't know what happened here, but something went crazy because here we go. All right, so let's go. Share again. There we go. Anyway, e to the 1, like I was saying, because you moved it 1 spot, and positive because it's larger than 1. And I'm just going to do every other. So the next one, number 1, oh, I forgot about that too. You need to pay attention to how many sig figs you have. This one really only has officially 3. So you want to just keep those 3 in your scientific notation. Okay, oops. All right, and then like I said, I'm just going to call it E. Oops, sorry. I said I'm going to call it E, and then I just didn't do it right. Okay, E to the, since we moved it 3 spots back, it's E3, right? All right, the next one after that, we count every single one of these as sig figs. So we got quite a few. It's 4.58212. And then you moved it that many spots, so that you moved it 1, 2, 3, 4, 5 spots, so E5. And all of these so far have been positive, but we're about to do a negative. So this one is less than 1. Therefore, we are going to remember that we still want the same thing. We want it to be, the first one has to be between 1 and 9, right? The first one to the left of the decimal. So when we moved it 3, so it's -3. And then again, this one, J right here, I right here is only 4 sig figs, so we only keep those 4. And we elevated to the power of 3, 6, right? So we moved it 6. And there you go. And that's how you do it for these in particular. All right, like I said, we're going to do every other. So we're starting with A. So if you want me to, I'll put the answers that I've given you in red. And remember, E just means 10 to that. That way it just takes less time for me to put it in. E is exponent. Okay, there you go. All right, so let's do the next one. Now we're doing the opposite. We're converting it from scientific notation. So the process is exactly the opposite. Since it is negative, you know that it's going to be, oops, see, this is what happens when you're too close to the, there we go. I don't want you, where? It doesn't, okay. 0, this is going to be 0.1, 2, 3, 4, 5, 6. and then 6.3. And that's how you know. This one is 5. And let me bring it back down. I don't know why that one stayed in small, but this one shouldn't do that. Let's just make it bigger. I don't know why it did that. There we go. I might as well make it red while we're at it. Okay, so oops, that one's the wrong one. We're doing letter C. And that is to the -4, again, 0.123, and then 5, 6. The next one that we're doing is E. I know I'm going crazy on these, going around the wrong way. A, B, C, D. No, that's right. It is E. Never mind. So for this one, why is it doing this? This is so crazy. It's like it's getting super small all of a sudden. All right. So this one, it says to move it in a positive direction, right? 2 spaces. So it's 7. 5 would be the second one, and then 6, the second digit, and 6 would be the third, then 0.8. And that is it. That is how you convert it to scientific, from scientific notation. All right, G is the next one we're doing. And for this one, we need, let's see, we need all those that are there plus 6 more zeros. So 2, 1, 2, 3, that, oh, sorry, 1, 2, 3, like that. And then 1, 2, 3, 4, 5, 6 zeros. And that makes it to the 9. 3, 6, 9, yeah, okay. And then I is the next one we're doing. Sorry, I just tapped it over. All right, I is the next one we're doing. Again, it's negative and it's telling you to move it 1, so 0.85. And that is the answer to that one. And that is all of these. Now, conversions, I'm going to go ahead and put in some conversions on here, put in a little table, just a 4. I'm going to always do a 4 just because they're conversions and I want to make sure that you see them. Okay, so basically you're, oops, I don't want it there. Why on earth did it put it where I was not? I want it right here. Sorry. Okay, so insert it here. See, it's not letting me insert it. Okay. Insert a table. I'm just going to make it 3. Okay, because this one's not going to need that many. Okay, so you've got 8.79, right? E, I'm just going to say, like I said, E -4. Just converting it from that, and that is liters. Okay, so we know that 1 liter, right, is equal to 10 to the 1 e to the 3rd milliliters. And we know that, milliliters. So we know that a milliliter and a centimeter cube are the same, basically. So we can just do that if you want. 1 milliliter is equal to 1 centimeter cube. Okay, so we know that. So basically all we have to do now is multiply. Oops, nope, not you. I don't want you. Sorry. Nope. It inserted something I don't want. Hold on, let me uninsert it. No. Delete. Yes, the whole row. Okay, there we go. All right, so for that, there we go. Now I can get the answer. I'll just put the answer in this next little block. All right, so you're just multiplying, right? So remember, when you multiply, you add the exponents. So it's just going to be 8.79 e to the negative 1. And that is centimeter cube. Okay. All right, let's tap this one down. All right, now C, we're going to do the same thing. I'm going to insert another little table. It's just so that you can see not the scientific, but the dimensional analysis that I'm doing with it. All right, so milligrams, remember 1 milligram is equal to, where we want to go? We want to go to grams. So this is 10 to the negative 3, oops, sorry, E1, I forget that one, e to the negative 3 grams, right? So that's it. Basically, we don't need the second half, but we'll just leave it there. I always put it on there just in case we need it. All right, so then this answer would be, if you multiply, divide, it's just going to be 117 e to the negative 3, but remember, you are going to have to move back 2, right? So if we move it back 2, 1, 2, we're decreasing it by 2, so we need to increase this by 2. So it's going to be 1.17 e to the negative 1, and that would be grams. Don't forget the units. I'll go ahead and color the answers in red so that way you'll know which one's the answer officially. Okay. All right. There we go. All right. I'm going to tab that one over too because this is getting my nerves. All right. E is next. And we're going to insert another one of those tables. A 3 would be good. I mean, if we don't need a 3, it's okay. You can just ignore the other half, but at least we have as much as we need. So 101.3, you notice is centimeter cube. And they wanted to change it to meter cube. So this is not one that we can say we're going to change it to liters or to milliliters. So for this one, what you need to do is you need to say that 1 centimeter cube this way. Oops, sorry, this way, because you actually have to cube everything since we do not have conversions in cube. We need to make our own. So then the next one is 1 e to the negative 3 cubed, right? Is in meters. Okay, so that is our answer right there. So basically the answer is, oops, nope, that's not what I meant to do. I meant to put it here and click on. Okay, so the answer is going to be 101.3 e to the, remember when they're outside of each other, they multiply, so e to the 9, and now it should have been negative 9, sorry, negative 9, because we're multiplying the negative 3 that is inside the parentheses 3 times. So basically we're cubing it. All right, and that is meter, but we're not there yet. So now we're moving it back 2, right? So 1, oops, no, don't want to erase it. I just want to move it. 1, 2, that is, we're decreasing it by 2, so we increase this one by 2, and that gives us 1.013 e to the negative 7. You see that? And that is meters cube. Oops, sorry, cube. And then this is the answer, so we're going to put it in red. All right. Next one we have is, it's hard to tell which ones I'm doing. So E, F, G. So it would be G. I'm going to insert the table in there. Just like I said, it's just for conversion purposes. All right, so G that we're doing is 2.5 liters. And we're changing to milliliters. So 1 liter, we know that, is equal to 10 to the third. or E, 1, 1 e to the 3 milliliters. Remember, e to the 3 just means the same thing. All right, and so that when we multiply, it is 2.5 e to the 3 milliliters. So this time we didn't have to move anything or do anything. This was a very easy one. So let me go ahead and put the answer in red, like I said. We just put it there for now. Let's see if we have enough room. The other times we don't have enough room. So, all right, the next and last one that we're doing is I. And I is going to change from milliliters to liters. So it's the opposite of what we just did. So 5.36 milliliters, where you have is 1 milliliter. And I like you always do the multiplication rather than division. So I just like to put 1 e to the negative 3 on top for the liters. Okay, and then the answer again is just plain old 5.36, right? E to the negative 3, sorry, liters. Oh, what happened to my E? I pushed the wrong thing. Okay, there you go. And that is your answer for this particular one. All right. So those are the answers for those. And you can kind of tell which ones I'm doing because of the beginning of it, right? If I could put I or whatever, but I think you guys are good. Okay, now, sig fig wise, how many are there? You guys know these? You can tell me. How many in the first one? An A. Okay, if you're doing it through the chat. Yes. Yes. Yes, you are. This is your, you notice I'm only doing half. So this is the one that gives you 10 points if you turn this one in and 15 for the other one. And they go directly applied to your final exam. So basically it's a 200 final exam. So you can recover 25 points if you do all three. Oh, I mean, all of them, both of them. All right, so how many sig figs? Oh, I'm just gonna go ahead and write it in since nobody probably is talking today. All right, that one's 3. This one, okay, since this is a conversion, they're really infinite. So I don't know. So this is basically unlimited. Why? Because it is a conversion. So whatever you're converting is what determines your significant figures. So unlimited here, but limited to whatever you're converting. All right, the next one, this one has 4, right? You can see that because all of them count. G has 2, right? Because that's all the significant figures. There is no decimal, therefore it only has 2. I has only 1. Doesn't matter if it's squared or not, it is still just 1. And that's it. All right, as far as sig figs. Now, with the temperature, remember, we have to apply the correct formula. So we're going to do A first. For A, what we need is, we have 115 Fahrenheit, right? So Fahrenheit minus 32 divided by 1.8 is what you're going to do. So let's do this in parentheses, right? And that's going to give us the answer in Celsius. Oops, sorry, in Celsius. So that is 100 clear, 115 minus 32 divided by 1.8 equals 46.11. And that makes sense because Celsius is always lower. So if something doesn't look right, it's probably because it's not. And I'm just gonna do one, just one extra, and it has nothing to do with the amount of decimals, although there are the amount of suffix. I mean, there are only 3. I'm just like, I like to give my answers to 1 decimal. All right, so the next one would be Fahrenheit. So I'm just gonna bring it down here so we can do that one. All right, so you're going to Fahrenheit. So this time, oops, okay, let's just do it next to it then. You'd have to multiply 19 Celsius times 1.8 and then add 32 for this one. Okay. That's going to give you the answer. So it's 19 times 1.8 plus 32. And I get 66.2. And that is Fahrenheit. And it makes sense again because 19 is much lower than Celsius, which is correct. I mean, Celsius is much lower than Fahrenheit, sorry, which is correct. All right, so next one we have is, let's see, here, we see, so E, Kelvin to Celsius. Okay, so for this one, we have and we're gonna do F also. So for Kelvin to Celsius, you just have to subtract from 598 Kelvin, right? You have to, well, let's just not do Kelvin, but we have to subtract 273 to get our answer, which is equal to 598, right? Minus 273. 325. And yes, that is a big number, but that is the number. All right, and that is Celsius. And then this last one that we are also doing, which is our Kelvin. I'm just going to scoot it back here. All right, we're going from Fahrenheit to Kelvin. So there is no direct connection. So we need to change the Fahrenheit first, right? So we're multiplying it times 1.8. No, sorry. We're subtracting 32 from it because we're going to Celsius and then dividing it by 1.8. And from there, we're adding 273. So that's actually the whole process to do that. All right, so let's see what we get. So it's 23. So it's going to be negative, obviously. Oh, so lower, the Celsius, I mean, are going to be negative. I got -9. Well, not yet. That might haven't divided yet. -5. And then we adding 273 to that, which is going to give us 268. There you go. All right. So that's how you do those temperature ones. Like I said, I'm only doing some of the rest of them are yours for you to do on your review. And if you want to turn it in, that would be better because it is let me do 4 on this one. It is a bonus opportunity. Okay, so notice that it says what volume of water would be needed. So this is the question right here. What volume of water would be needed to have the same measurements? Okay, so basically this is our question. We need to multiply 5 times 4 times 15. And that would be, the answer would be in centimeter cube, right? Right? So once we get that, then we can use the density of gold over here first. So the 1 centimeter cube, sorry, goes on the bottom, right? Because we want to convert it. And then the 19.3 grams goes on top. But remember, this is gold. All right, and then now what we need to do is use the density of water to convert that volume that we just found to the volume of water. So basically it's a 1-to-1, but you know, just let's pretend that we need to do it. So, which really we don't, but that's how it would go. Okay, so this is water. I'm going to put it in blue just because it's water so that we don't get it confused with the other one. This one is water. So see, this is what we're converting the volume of water now because we use that other conversion. So now let's do the math. It's 5 times 4 times 15. That gave me 300 cubic centimeter. And then that multiplied times 19.3 gives me the mass of gold, which is 5,780 grams. I mean, right? And then since it's a 1-to-1 situation, we know that it's 5,780 centimeter cube of water. However, we definitely have to go with, well, actually, no, we're not. We're not going to go with it. Okay, so if we went with sig figs, we know that the actual number of sig figs we have is 1. So that it would be 6,000, which centimeter cube, which kind of, it's a lot. That's with sig figs. Okay. That's the actual answer with sig figs. Oh, where did it go? I changed it to red and then it changed back. Okay, there we go. There. All right, the next one that we're going to do is how many seconds are in a leap year. If anybody can tell me how many days are in a leap year, then we can do this. So 1 LY, I'm just going to call it 1 LY. So there are 1 LY has 366, isn't it? Because we have 1 extra day. And then for 1 day, and I'm just putting D for day, we have 24 hours. Ooh, we're going to need another. I need to insert another. Oh, hold on. I need to insert one more. So, there we go. All right, so for 1 hour, we know that 1 hour is, because they asked us for seconds, is 60 minutes, right? Oh, we need another one, yet another one. Why are you not letting me insert? Yeah, there it is, insert to the right. Okay. And we know that 1 minute is 60 seconds. Oh no, so we didn't need another one. That was it, 60 seconds. All right, so the answer is going to be, I'm going to put it here too. So basically we got 366 times 24 times 60 times 60, right? And that gives me a lot. So we're going to have to do this in scientific notation. So that is going to be equal to 3.2 times 10 to the, so E, to the 7th seconds. Okay. And there you go. And like I said, I'm putting the answers in red so you can find them easily. All right, and that's that. Okay, the next one that we have is this one. Again, This density grams per liter, this is pretty much a study in uselessness. You'll see why in a minute. But it is a good way to use conversions double. All right, so this is double conversion. So we have 23.7 milligrams, milligrams in a milliliter, right? That's what that means. There are this many grams in 1 milliliter. All right, so now we want to change milligrams. So 1 milligram, you'll see why I say it's a study in uselessness. 1 e to the, we're changing it to grams, so -3 grams, right? And now we're changing the milliliters. So see, milliliters started down below, so we need to start with the milliliters above. Why? Because we want to be in the opposite place that it is in. All right, so then this one's 1 e to the -3 liters. Okay, so the answer is actually what we started with, right? Because we converted both of them to multiply both of them times -3, and that's like negating what we're doing, right? That's why I said it's a study in uselessness, and that's why. All right, so we're going to do this last one also, only because I want you to do another double conversion, one that actually does make sense. So we're going to do another table of 4, and we want 115 kilometers in 1 hour, right? That's what it's saying. All right, so first thing we need to change is the kilometers. So one, let me see, I have to have my, no, I did not get it. Let me go get it real quick. My conversion table. I thought I had it here, but it's in my bag, which is not in here. Okay, I'm back. I am back. Sorry. I just had to go get my conversion tables. I didn't bring it with me for some crazy reason. So converting from kilometers to, what is it we want? We want meters per second. So that's not too bad. All right, so, but we're gonna need it for later too. So I needed to go get it. Okay, so 1 kilometer, right, is equal to 1 e to the 3rd meters. So that's all we need there. And now we want to change 1 hour. And this is going to require a few more of these. So we're going to have to insert 2 more at least. Okay, there we go. All right, so 1 hour. Remember, 1 hour has to cancel, so it has to be on the opposite side of where it is. So if it's on the bottom, it needs to go on the top. That is going to be equal to 60 minutes, right? Okay, so I might not need it that many. And 1 minute is 60 seconds. Okay. Yeah, I didn't need this one after all. Just okay. So when we multiplying, we are multiplying just as what it says on the top and then dividing it by what it's on the bottom. So I would use parentheses. So it's 115 times 1 second e to the 3, right? Divided by 60 times 60. That gives me 3.19. And yes, we can have 3 sig figs. And that would be meters per second. Right? That's our answer. Times 10 to the 1, sorry. E to the 1 meters per second. So basically 31.9, right? So if you want to call it 31.9, it's fine also. It depends on what they ask you on your, that's also acceptable right there. It just depends on what they ask you for in your test. Sometimes they'll give you the answer in scientific notation because it's multiple choice, right? And you will see it like this. So you should be able to know that that is the same as the one on top. Okay, so here we are converting. We're going to only do 2. And by the way, that's supposed to be decimeters. I don't know why it didn't change again. That's decimeters, not the same. All right, so we are changing the first one. Again, we're doing the same thing we've been doing. We're inserting a table because it's always good to have the conversion factors lined up. All right, so we're just doing 1 meter square. And remember what I told you about square meters. They do not exist officially. So you got to change the conversion by squaring, right? And then on top, you want to change it to millimeters. So that would be 1 e to the, since it is milli, so it's to the 3rd squared. And that is millimeters. So in this case, this one's easy. Oh, sorry. I'm going 2 meters squared. Oops, I did it backwards. All right, sorry. Millimeter squared. And that should be millimeter on the bottom. And this is -3. Okay, so see, the only thing that's changing is the actual sign. Okay, there you go. And that meter squared, obviously, is going to be inside. So I should put meters inside here. There we go. Okay, so everything's squaring. All right, so when you multiply 1 times 10 to the 3rd, 10 to the 3rd, and square it, that's really 10 to the -6. So the answer is 1e -6 meters squared. Okay. And then, oops, that's supposed to be an E, not a 3. Sorry. And there's your answer. Basically, when you, like I said, when you square or cube or whatever, something in a parentheses that has an exponent, you're just multiplying those exponents. All right, this next one, C, we're going to do one more. And it is going to be that one. I think we need only 3 for this one. So I'm just going to save myself a trip here. All right, so we're going to millimeters, right? So millimeter cube. All right, so millimeter has to be on the bottom, but remember, I'm not cube, sorry. squared. And we square that, which means we need to square the top. And we're going to change it to centimeter. So we know the difference between 10 to the third and 10 to the -3 and -2, if you were doing in meters, or in third and 2, it's 1. So basically it's 1 e to the 1, right? Actually, we're going up, so it's -1. Remember that? I showed you that, and that is centimeter, and then we square it. All right, so since we're going up, right? Remember that. I don't know if you recall that, but the direction is what gives you the sign. So if you're going up, you're going from low to high, which means that the sign is going to be negative, because you're only going to get a fraction of what it is on the bottom. If you're going from high to low, so top to bottom, then you're going to be positive, because you're going from a high one to a low one, and you're going to end up with, well, obviously, more of them, right? So 1 e to the -2, and that would be centimeter cubed. See? So these are easy to convert. I didn't put any numbers in front of them. I just wanted you to make sure that you knew how to convert them, period. All right, and that's all of them. All right, so these two are drug interaction things, which you as a nurse or any kind of health professional may have to do at some point, drug calculations, I meant to say. And sometimes it can be dosing or whatever it might be. Oops. Okay, I do not want you there. I want you afterwards. Sometimes this thing. Okay, so I think I might need 4. It just depends. Okay, so the first thing you need to know is what they're asking you. So they're asking you for 30 days, right? 30 days. What did they give you that is 30 the day? See right here, this is your first conversion factor. So for 1 day, you get 125 micrograms. And I'm just going to call it UG, right? Or you can call it MCG if you want. Let's call it MCG. All right, so they're not wanting in micrograms, though they're wanting it in milligrams. So again, we do that same thing we did before. 1 MCG, we're going up. So for every MCG, we will have 1/3, right? I mean, 10 to the third. So 1,000th, right? Because it is 10 to the 6th. So, sorry, 10 to, well, it depends on how you're looking at it. 10 to the 6th and 10 to the third. So 10 to the third to 10 to the 6th is negative. It's subtracting, it's 3. And we're going up because, so it's -3. E -3. And that would be grams. And that's it. There's your answer. So the answer is 30 times 125 times e to the, 30 times 125 times 1 second e -3. That gave me 3.75, and that is grams per day. There, that's your answer. And you notice I didn't cancel out days, right? Because days is not, actually I did cancel out days, but that is what they wanted to know. Actually per month, per month is what it should say here. There. Because that's what they asked for. How much is it in there? 1 month supply. So if you wanted to actually put here 30 days equal 1 month, that would give you that month on the bottom, okay? In their case. All right, the next one that we have is a pain reliever. And this one, again, I'm gonna go ahead and insert a 4 again, because we never know how many you might need. All right, so this one says the question. See, look at what the question says. What is the, how many grams? So all of that is important to know. How many grams of it are going to be in one day, right? Per day. That's what they want. Because you cannot exceed that dose, right? Okay. So the question is where we have to end up. But what is what they gave us? They told us that we have 30 milligrams per coating per tablet. So we can put that in 30 milligrams for one tablet. And I'm just going to call it a tab, so I don't have to write the whole word. All right, next one, you notice it says there's another conversion factor. See, each one of these are conversion factors. Okay, let's just make this green to change the color just so that we know that that's the end of it. Okay, and then this is another conversion factor. You see that? See, they gave us all the conversion factors sitting in front of us. So we've got the first conversion factor. We need to connect milligrams to tablet. We did that. Now we need to connect tablets to 24 hours. So 24 hours is going to go on the bottom because we want tablets on the top. Okay. So once you do the math, you can see, oh, and they want it in grams. So now we need to change that. 1 milligram is equal to 1 e to the negative 3 grams. Remember, that's, oops, that e always pushed the wrong thing. I don't know what it is. Okay. All right. So 30, basically what you're doing is taking 30 times 8 times 1 e to the negative 3 equals, and then dividing it by 24. So the answer is 100. That what you got? Then that's what you got. The answer is 100 grams per day, right? So 24 hours in a day, you could always have put that in there, but I didn't feel like we needed to because the actual question is that. All right, so again, 30 milligrams cancels with the milligrams done there. The tablets cancels with this tablet, and the hours stay, so that's a day, you see? So, all right, so 30, or you can say in 24 hours. You can do that too. Oh, that's what I did. I knew there was something wrong. That should be 1 day. No, there shouldn't have been any division. Sorry. Nope, no division. Because it's per day. They don't want to know per hour. That would have been per hour. And we don't want that. So it's 30 times 8 times divided. So the answer is actually 2.42 grams. Times 10 to the 1. If you want it like that. Like I said, it depends on how they're asking, or 24. You can always call it 24.2 grams, right? Per day. Okay. All right. So I'm just making sure it's correct. 30 times 8 times 1 to the negative 3. Yep, I get 2.4, or you can just say 24. That's good enough because we don't have that many sig figs. All right, so there you go. All right, this one, it's pretty obvious, and I'm just gonna put solid, liquid, and gas. So solid, obviously this is solid again. This one is actually gas. Air is also a gas. Hydrogen in the sun is actually plasma. And vegetable oil is a liquid. And there you go. All right. Now, chemical or physical. All right. Electrolysis of water. Electrolysis means you are breaking it up. So that's a chemical. Formation of fog. Oh, wait, sorry. Separation of a water, alcohol water mixture is physical. Formation of fog, again, is physical. Burning wood is going to be chemical. Rusting iron is chemical. And the last one, sand to glass, all you're doing is melting it. So it's physical. Okay. Draw a graph of temperature. Okay, so for this one, you don't have to draw it, but you can go to your here in matter. You notice it says energy, right? See how it says, let's see, energy, temperature, right? So we're going to go to the one that says temperature and energy, which I think is our first one. But we're going to find it. Let's see. I do believe it's our first one. Where's matter? There it is. Okay. So it's this one right here, if I'm not mistaken. Yeah. See how it's temperature, heat is energy. So that's it. That's the one. Okay. So just, you can copy it. Let's see. How do I do that? Let's see. Can I copy you? I could not copy you. Okay, I'm trying to copy it, but but it's not letting me. So let me see if it'll do it when I do Control C. I don't know if it'll do or not. Let's see if it did. If it didn't, that's fine. It doesn't matter necessarily. I'm just trying to demonstrate. So go back to our thing and let's see if it actually did do it. If it didn't do it, that's fine. You can figure out how to do it on your own time later. Okay, where did you go, graph? There it is, right here. Ah, nope. It did not. So let's undo that. Sorry, it did not do it. So it didn't Control C anything. All right. But actually, if you just download it, print it, and then you can put it in there. Okay. Crop it, all that good stuff. All right. So for each of the following mixture, solution, or compound. Okay. So soda pop is actually a solution. Sugar is a compound. Milk is a mixture. Why is milk a mixture? Because it's homogeneous. But because we homogenized it, but it's actually heterogeneous. Officially. The official word for milk is a colloid, and colloids are heterogeneous. Muddy water is also a mixture, happens to be a suspension. Baking soda is a compound. You notice they gave us a formula. Pizza is a mixture, right? And bronze is a solution of metals. So yes, can have solid solutions. Oh, I just had apparently it didn't completely take us out, but okay, so these definitions, these are for you. You just look for their definition and put it on there. Sure you know them. Okay, this one's easy. I'm going to go ahead and add one more. Sorry. Here we go. I'm going to stick it in and I'm going to add one more. And